Alright, today is July the 21st, 2020, Tuesday, and we're going to show on this, which will be our second video, TP7, the output of the delay angle command going into the LSI for the X bridge with respect to test point 5. Then we'll repeat the same thing for test point 10 and test point 12 for the Y bridge, while monitoring the output with a meter, with an oscilloscope, and also by looking at the value of a SIG-high, the delay angle command, with this scope right here. Alright, so the setup really quick is we take the 240, we bring it into a transformer. We have a step down transformer, it's a 240 to 120, and what we do is the secondary of the transformer generates our X and Y bridges at 120 volts AC. So let's go ahead and get started. What we have here, the board has been powered, the board has been cleared phase loss, and for this video we have test point 5. It's a 50% duty cycle at a frequency 5 milliseconds of 60 hertz, and we have the delay angle TP7 for the X bridge and the DC output of our entire 12 volts bridge. So we'll keep this signal for the second part of the video. We're looking at just the X, and we're going to start with SIG-high equal to 0, and we're going to do basically the potentiometer, bringing it in open loop. Go ahead, Tony. So there you go. We see, you can stop there. We have an output, and again, if we were to look at the 16 milliseconds, which is right here at the 360 degrees, if we were to come here, we will count those 12 humps on the output. We also notice that the delay angle, it's moving along. Go ahead, Tony. Can you bring it slowly, bring it up, and slowly bring it down? And one of the things that I'm going to roughly do here on channel 1, I'm going to bring this down so that we can see that this coincides with an SCR. Go ahead, Tony. And we can see that, yes, this right here, the leading edge here, it's coinciding with this SCR. Can even bring it up here. See that at some point they're matching, and of course it will match. Each one of these signals will match. So can you go high, Tony, as high as you can? Okay, so we are at 6 volts. Now here we got again the 12 humps. Now we have our duty cycle that it's maximum. This reference never changed. And let's go ahead and calm down with a 0. And we are looking at the duty cycle of that channel. We can measure the delay angle. We've given you a formula, and we also are recording the DC output, which is also here. Now we're at -0. Can you go once again, Tony, since we're looking at main parameters? And we're going to concentrate here. 2 volts, 3 volts. Can you stop there? 3.27. We are at 56. Go ahead, Tony. Go all the way to 6. Okay, and now we have right there is good. 278 volts. That's the output when the AC input is 120. And again, we can see the maximum duty cycle of the blue channel. TP5 never changed. And now let's go ahead and calm down. Alright, let's bring it back to 0, Tony. Now I'm going to ask you to please inhibit the board. And I'm going to really quick move TP5 over to TP10, TP5 to TP10. Okay, just right here, right, Tony? Right there, even marked AX. All right, and we notice here even the 30 degrees because I haven't moved this here. And now I'm gonna move TP7 to TP12, which is right here, right, Tony? Yeah. Is that it? Yeah. Alright, so now they coincide again. If I move it back to TP7, I can see the phase shift. These two are no longer phase. We can see this 30 degrees phase shift here. Now if I move it off, because I'm looking at the X and the Y, if I bring it back to look Y and Y, now we can see here the trailing H matches for the two. And we basically go through the thing. We enable now, and we start bringing in SIG-high, and again we see the corresponding delay angle. This duty cycle increases from this H. Go ahead, Tony, bring it back. Which is actually this right here, the trailing H. We see the 12 humps, and we can see again that we have all the 6 SCR firing. Go ahead, Tony, bring it back again. So we are at 0, we're negative 4 volts, and when Tony gets to 6 volts DC of SIG high, we have the same 278 volts DC. And again, if I were to count, let me move this here. If I were to count this here, of course there's a phase shift that we have the 30 degrees right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And there's right there again. This is because we have a 30 degree phase shift. This is the end of this video, which will be video number 2.